Hey everyone, and welcome to this explainer. Today we are unpacking a really fascinating and honestly highly publicized intersection of celebrity influence and cutting-edge medical technology. You've probably seen the headlines floating around about the Chris Hemsworth Smart Senior Health Tracking Protocol, right? It's this massive campaign backed by serious star power, and it's completely focused on using AI vitals monitors to revolutionize how we care for the elderly. The promise here is just incredible. Imagine active seniors living independently, but surrounded by this invisible, predictive safety net. But, well, you know how it goes. The gap between slick consumer marketing and actual clinical reality can sometimes be pretty wide. So today, we're going to look right past those shiny endorsements and conduct a rigorous professional technological audit of what's actually happening under the hood of these devices. Okay, let's dive into this. You see titles exactly like this everywhere. Chris Hemsworth's Secret Smart Tech, the AI senior health monitor saving lives. I mean, it's a brilliant click-maximizing title perfectly designed to grab your attention. And hey, it totally works. But for us, as caregivers, wellness advocates, and clinical providers, we really need to transition away from the hype. We've got to evaluate these wearable health trackers and remote vital software platforms not as some kind of magic gadgets, but as complex engineering systems. And like literally any engineering system, they are susceptible to flaws, glitches, and outright failures. Our goal today is basically to equip you with the knowledge to navigate these tools safely. To do that, we're going to quickly run through today's agenda. First, the promise of smart tracking, followed by calibration and algorithmic glitches, then the danger of signal dropouts, privacy risks, and data leaks, and finally, diagnostic compression artifact errors. Let's start right off with Section 1, the promise of smart tracking. Before we really start critiquing the tech, it is absolutely crucial to understand the immense potential driving this whole industry forward. Geriatric health tech isn't just a passing trend. It is a fundamental shift in how we approach aging. And right at the core of this is remote patient monitoring, or RPM. Now, in a perfect world, these digital health tools integrate multivariable vital statistics. We're talking heart rate, blood oxygen, movement patterns, even sleep cycles, to coordinate active elderly care monitoring. It effectively extends the reach of a clinical setting right into a patient's living room. This allows seniors to maintain their independence while still staying medically supervised. It's a real game changer when it works. So, why does this matter so much right now? Well, first off, we're seeing massive growth in remote patient monitoring structures, specifically within geriatric health. Second, and this is probably the most exciting part, we're witnessing the integration of predictive AI models. These algorithms aren't just passively logging data anymore, they're actively searching for anomalies. They're designed to provide early fall detection and spot cardiovascular risk factors way before a major event even happens. And finally, there's a renewed focus on user-friendly interface designs tailored directly to older demographics. This makes the tech feel accessible rather than super intimidating. All of this is rapidly changing the landscape of active senior care for the better. All of that sounds fantastic, doesn't it? But it brings us to a really pivotal question, and honestly, the absolute core of our explainer today. But is this technology actually safe? When we strip away the slick Apple Health interfaces and the big celebrity endorsements, are these systems clinically robust enough to trust with human lives? Let's shift our narrative to a stark clinical breakdown of system vulnerabilities. Moving on to Section 2, calibration and algorithmic glitches. Now, what's really interesting here is how it shows that diagnostic systems are literally only as smart as their baseline data. Notice the stark contrast between a calibrated baseline and a completely miscalibrated one. Think about popular consumer trackers for a second, like a Fitbit. These devices learn your quote-unquote normal over time. A properly calibrated baseline knows exactly what an active senior's resting heart rate should look like. But what happens when the device gets it wrong? Mismatches start popping up everywhere. The software diagnostic system begins utilizing completely inaccurate historical reference metrics. It essentially starts thinking abnormal is normal or normal is abnormal. The real-world impact here is incredibly disruptive. Contradictory baseline averages trigger false warning states. So picture this. Algorithmic errors referencing these miscalibrated baselines might send out panic alerts to caregivers when a senior is, simply drinking a cup of coffee. Or much, much worse, because the baseline is artificially elevated in the system's memory, the AI might completely fail to trigger an alert during a genuine developing cardiovascular event. The technology essentially blinds itself to the real danger. Okay, Section 3, the danger of signal dropouts. Let's move to and see how this builds into our next critical vulnerability. Here, we're looking at the literal invisible lifeline between the patient and the healthcare provider. Because, let's be real, even the most perfectly calibrated AI is completely useless if the data cannot reach the cloud. Consider biometric telemetry platforms, like those utilized by Garmin devices. The reality of disjointed remote network feeds means dropouts just happen. Walk through this dangerous chain reaction with me. Step 1, the remote sensor disconnects. Maybe the senior just walked into a Wi-Fi dead zone in their kitchen. Step 2, on the clinician's end, the real-time ECG telemetry chart simply flatlines. It just drops out completely. Step 3, active care oversight is instantly interrupted. And finally, Step 4, because of this gap in transmission, life-saving emergency responses are delayed. A simple technical glitch in synchronization can literally cost minutes when seconds absolutely count.
Section 4. Privacy risks and data leaks.
So, the crucial point is, we've talked about hardware transmissions and algorithmic baselines, but we absolutely have to address software security and the alarming reality of how patient medical data is handled once it actually reaches the servers. The key vulnerability we're looking at here is plain text exposure. When we trust remote patient monitoring systems with our most intimate health details, we kind of just assume bank-level encryption, right? But audits of certain RPM dashboards have actually revealed severe security lockout states where this is not the case at all. These issues mostly stem from unsecured RPM servers. For example, we've seen instances like the vulnerabilities tracked in certain 8-sleep dashboard layouts where there is plain text exposure of private patient records. This means that if a database leak occurs, hackers aren't getting a jumble of encrypted code. No, they are seeing unmasked patient IDs and deeply personal clinical logs plain as day. Secure databases are absolutely essential to protect elderly patients from these massive privacy breaches. Yet the rapid rush to get these products to market sometimes leaves these digital backdoors wide open. Finally, Section 5, Diagnostic Compression Artifact Errors. And this brilliantly illustrates how the visual data itself can actually fail the clinicians who are trying to read it. Just look at the visual evidence of the problem. On one side, you've got a sharp, high-resolution microcellular biological scan, a perfectly clear electrocardiogram pulse frequency. But on the other, you see this blurry, pixelated version. Why does this happen? Well, to save bandwidth and battery life, these wearable tracking frames aggressively compress the medical visuals before sending them over the network. The patient impact here literally cannot be overstated. Low-quality signal compression literally obscures critical cardiac variations. When a remote doctor looks at a highly compressed pixelated heart signal scan, the fine nuances of a microarrhythmia are just smoothed right out by the software algorithm. This loss of high-resolution biological detail directly obstructs vital cardiovascular patterns, and that can lead to serious, life-threatening diagnostic errors. The clinician thinks everything is totally fine, simply because the compression artifact effectively erased the warning signs. Which leaves us with this final, incredibly crucial thought. How do we balance adopting life-saving tech with navigating its hidden, life-threatening engineering flaws? The Chris Hemsworth-backed vision of AI senior monitoring is honestly beautiful, and it holds incredible promise for the future of active aging. But as we've explored today, from calibration mismatches and signal dropouts, all the way to privacy leaks and compression errors, we absolutely must approach this technology with a critical, informed eye. It requires real vigilance from both caregivers and clinical providers to ensure these tools actually protect the ones we love. Thank you so much for joining me for this explainer, and remember to keep asking the tough questions.